let me give you some hints on some of these. So if you look at question 14, a normal freezing point of 1 propanol is negative 127 degrees. So right away, you see that it is critical based upon a temperature. So as soon as you see that it is critical based upon a temperature, you either know you have positives or you have negatives. That's it. So as soon as you see that it is critical based upon a temperature, there's only two things that can happen. They're either both positive or they're both negative. That's it. Now, when you get to a question like C, at what temperature range is it non-spontaneous? You want to answer that in terms of, of below a certain point, or below or above a certain point, okay? It's not going to be within a certain confine. It's just going to be above a certain point or below a certain point. So when you look at question like 31, what do you expect? And this is why on 31, just do A, don't do B. That's why I marked out B. So what do you expect from the sign of delta S in a chemical reaction with 2 moles of gaseous reactant converted to 3 moles of gaseous product? So you're going from 2 moles of gas to 3 moles of gas. What's going to happen to the entropy?
Increase.
No, it's going to increase because gaseous particles have so much more entropy than liquids or solids do. So when you get to like 54, a certain reaction has a negative delta H and a positive delta S. Okay? Now, you have a negative delta H and a positive delta S. Is this going to be temperature dependent?
No.
Why not?
Because on the notes it says spontaneous.
Why?
That's what you said.
Oh dear.
Because
But why did I say it?
Because in the formula, there's no way for it to
There's no way. What is it?
to like the spontaneity of it or whatever.
It's
The delta G.
How about the delta G?
That's what I meant. Yeah.
What are you talking about?
So on number 54, you have a negative delta H that's in kilojoules. It's actually kilojoules per mole. They didn't put the mole there. Then you have a delta S, which is in joules per Kelvin. Again, pay attention to the units. Do not just randomly write these numbers down. Pay attention to the units.
Should I tell Jonathan that?
Huh?
Should I tell Jonathan that?
Yeah, he can figure it
Yeah,
out.
where's John?
So,
He's busy.
now, when you get to 44, let me give you the hint on 44. Cyclopropane and propylene isomers. Isomers just means they have the same kind of chemical structure, but you arrange how the atoms are located. If you ever take organic chemistry, you'll spend a lot of time studying stuff like that.
So you already do that, right?
It says, based upon the molecular structure, which of these isomers would you expect to have the higher standard molar entropy at 25 degrees Celsius? So, entropy is a measure of kind of how jacked up it could potentially be. So, which of those two structures looks more unbalanced?
The second one.
The second one. Okay? You got a double bond, it's not symmetrical. That means that basically the more things that can go wrong, the more entropy that you're going to have. So all you have to do to answer that one is just look at the structure of it and go, okay, well, if that second one's not balanced, that's going to be more jacked up. So it really isn't temperature dependent. You just have to look at the structure.
Is jack
Okay.
a scientific term?
Horribly.
Kinda, yeah, but I don't recommend that you use it.
No, it's not.
Okay, Mara.